Welcome to the NULLCON Webinar series. My name is Harshit. I'm a part of NULLCON team. We have been running NULLCON Security Conference since 2010, where cybersecurity is discussed in detail among the industry, government, and tech community. This pandemic has given us the opportunity to continue to share knowledge and connect with our global community by running online events like webinars, training, and resume clinic. We have our upcoming online training session happening from 7 to 10 November 2020. Do check out more details in the chat window about that. Today we have with us Aranguren, and he is going to present a talk on hacking modern desktop apps using XSS and RCE. Abraham is the CEO of 7 Security, a company specialization in penetration testing of web and mobile apps, infrastructure, code reviews, and training. He's also been trainer at Black Hat USA, HITB, OAPS Global AppSec event, and many other recognized events around the globe. I welcome him on behalf of all of us. Few instructions for the audience. During the session, if you have any question, you can ask using a chat option. The question will be answered after the talk by the speaker. And I also request you to keep your mic mute during the session. So without any further delay, I request Abraham to take a charge of the session. Thank you.
Okay. Can you see my slides and can you hear me?
Yeah, perfect. We can see the slides.
Excellent. So let's get started. So the first thing I want to say is that this talk is also a workshop. So if somebody wants access to the slides, the recording, the applications that I'm going to use during the demos to practice with, you can email admin@7security.com and we will give you access to all that for free. Right. So it's a webinar workshop presentation, right? So the same slides can work for a workshop, but today we only have 1 hour, so it will be a webinar. But you can still get access this way, like to all these applications to practice. So yeah, let's get started. So I'm the CEO of 7 Security. If you like this webinar, maybe you like to read public test reports. So there's a few test reports and presentations here on the publications link. I have delivered training at Black Hat USA, Hacking the Box, OWASP Global AppSec, and others. There's other, you can see what the schedule looks like here on the training URL. A while back, I also wrote a course for eLearn Security called Practical Web Defense about hacking and then fixing web applications. So it was kind of both attack and defense. I'm also the OWASP OWTF project leader. So if you type owtf.org in your browser, that takes you to the OWASP page. And this is an OWASP flagship project. Some presentations that I have delivered previously, you can see them here. And I also have like some security and development related certifications. So on the public reports, just a quick mention that the first, well, the maybe more interesting one is this one here about smart sheriff. So we painted this twice and we found a lot of problems. So the context was that in South Korea, the government mandated by law, they forced all the population to use this app, right? That parents were meant to use to protect the children. So the parent would install the parent app, the child app, and then the parent would control like this user will be able, this child will be able to access the website or use the mobile phone from these hours to these hours. They will not be able to access these websites and things like this, right? So a typical kind of political thing about to save the children, right? You get things approved. So the idea was nice in principle to protect the children, but the implementation was really bad. So everything that you should not do when you develop a mobile application, you can see in these 2 reports. So they are full of security bugs, really interesting ones. We gave a presentation about this, so you can see it on YouTube, and there's also slides here. And these are more kind of privacy related about the Chinese government monitoring Muslim minorities in Xinjiang. I also gave a talk about this. You can see it on the website on publications. Okay, and then there's other public pen test reports, right? So reading pen test reports is maybe a quick way to get started with security. So you have a lot of those there. So this course is also written by Anirudh Anand, who is a security researcher. He is a member of Team BIOS, which is the #1 ranked team in India for CTFs. He has also discovered the vulnerabilities in Google, Microsoft, LinkedIn, and others. He's also contributed to some open source projects like OWASP WTF, Hackademic, and Kukusetra. And then he also has some certifications, OSCP, OSWE, and EPWD. He has a blog, and this is his Twitter. I also would like to mention that this course was made much more awesome thanks to these people. So InsertScript, File Descriptor, and Masato, they all kind of helped in different ways to answer my questions and give the course like some twists that on my own I would have not been able to. So some of the magic you will see in the course comes from these people. So to take the course, what you will need is to have the ability to connect to wireless and wired networks, ability to read PDF files, administrative rights, right? Sometimes people come with a corporate laptop and they don't have access to deactivate the firewall or install tools and things like this. So it's better that you have a laptop with, appropriate level of access. You should have at least 8 gigabytes of RAM. If you have 16, that's even better. But with 8, I think you can follow the course without issues. Try to have plenty of 3D space, maybe 60 gigabytes or so. VirtualBox is recommended, but in this particular course, we have reports from students that if you use VMware, the VM import's fine, so VMware is also okay, if you prefer that. And then we will also use like Burp, or you can also do the exercise for Burp with Tab or Fiddler or another man-in-the-middle proxy, right? So now this is a little bit different than what other companies do. So you get access to digital copies of all training material, lab VMs, the test applications throughout the course, and you also get the source code for the test applications. But you also get lifetime access to the training portal, right? So this includes all future updates for free, step-by-step video recordings, slides, and lab PDFs, and unlimited email support, right? So you have lifetime access, and there's no, we will not ask you for money to get any update. You will get them all for free, right? So the way it works is you have access to the portal, and then whenever we update any PDF, like for example, this week, we have been delivering training at OWASP Global AppSec in the evening with Anirudh, and whenever some student finds a typo or something in the material, we fix it, or something maybe is not clear enough and it prompts a question, we also fix that. So all those fixes, as well as a lot of upcoming upgrades, you get all that for free, right? Okay, so with that, I'm just going to cover very quickly what the course is about, and then we'll jump into the actual hands-on exercises for this webinar, right? So first, we start with an introduction to Electron, because Electron is really nice because it allows you to write an application in JavaScript that will work on Windows, Mac, and OS X, right? So previously you would need like 3 different teams normally, like one team for the Windows application, maybe written in C#, another team for the Mac application, and another team for the Linux application, right? So now you can have a web developer that develops an Electron application using JavaScript, and with minimal adjustments, this application will work on the 3 platforms, right? It will work on Linux and Mac and Windows, so it is much more efficient, and this is why a lot of big companies like Slack or for Microsoft Teams, Bitwarden, Skype, like names that everybody remembers, right? So these many applications are now written using Electron for this reason, because you just write it once in JavaScript, and then it works on a lot of platforms, right? So we'll talk about how to reverse in this particular lab, how to reverse all the different formats for these platforms, how to analyze the preferences and the package.json file that the Electron configuration works with, and then we will jump into exploiting Electron vulnerabilities. Okay? So some of this content we will do today. right? So we will look at how to find vulnerabilities in dependencies, in the configuration and in the source code, the basics of Electron XSS exploitation, exploiting node integration, and Electron XSS and remote code execution mitigation essentials, right? So basically, what happens is with Electron, you have a JavaScript application that now works in a desktop computer, and then XSS can mean remote code execution sometimes, depending on the settings and other things, right? So this is what we're going to look at today, how to exploit these XSS and code execution issues against modern desktop applications written in Electron, right? And then in this lab, we also cover Electron negativity, which we will also talk about today. So then in the second, we talk about XSS and remote code execution with links, bypassing CSP, attacking preload scripts. We will do a little bit of this today, bypassing CSP, attacking Electron applications from Windows with SMB shares, zone identifiers, so all these kind of stuff, right? Attacking preload scripts with lack of context isolation, lots of fun stuff. And then another thing to bear in mind is modern desktop applications are still desktop applications. So there's some general desktop application attack vectors that also apply to modern applications as well as old applications, right? So some of the techniques that we will see will work against any desktop application, regardless of the language in which it has been written. So this is one example lab about this. So this one in particular looks at local leaks. So we will look at local leaks in Windows, Linux, and Mac OS, finding leaks on local storage, local file SQLite databases, and then we will look at reversing Electron apps, decompiling binaries, and debugging Electron apps, right? So all this is quite nice. Then we will take a look at man in the middle. So we call it the art of man in the middle because typically always there's something that goes wrong. So we will talk about troubleshooting and getting all these working. And here we will use Verb. We will show how to man in the middle Windows, Linux, Mac OS 10, right? So how to do the man in the middle in the three platforms. There's some things that are a little bit different in each of the platforms. And we will take a look at some of the techniques, like, for example, man in the middle through DNS spoofing, an S3 host, the NSSDB, that is sometimes necessary to manipulate to get man in the middle working in Linux and all things like this, right? And then we talk about repackaging, which is about modifying the applications, right? So we will reverse and modify Microsoft Teams here. We will reverse and modify Slack, and we will make like some changes to the app. We will change some text, some HTML, CSP. We will deobfuscate JavaScript, a lot of fun things like this. And we will also backdoor an application to get a Linux reverse shell on Microsoft Teams as well. Then we talk about instrumentation. So here we will talk about FIDA. We will use Bitwarden, right? So you will notice that we use like a lot of high-profile, well-known applications in the training. So there's some toy apps as well, but the toy apps have vulnerabilities that we have seen in real pen tests. And then we have created the toy app to practice, which has like a simplified version of the vulnerability for practice, but it's still from the real world, right? So there's no made-up vulnerabilities. So FIDA is really cool because it works on all platforms. It works on Android, iOS, and so on, right? And then you can use it on Windows, Linux, Mac OS 10. So it's really nice because it gives you the ability to monitor and modify what the application is doing in real time. So in this lab, we will look at that. We will trace methods, we will discover methods, and we will hook them and change things. And then we will also take a look at DevStrong and Chrome Inspect to inspect Electron applications, specifically in more depth, right? But all these FIDA stuff you can do against any application, right? So again, the content of the course is not just for Electron applications, it will work also on many other platforms, right? Then we finish the first day with a CTF, right? And in here, these are like open challenges for you to practice with some real applications and stuff, the real vulnerabilities that have been found in the field for you to practice. And then that is the end of part one, right? So in NULLCON, it will be 4 days. So what I have said until now will be the first 2 days, right? Which will be 2 4-hour sessions. And then in the next 2 4-hour sessions, we will cover part 2. So in here, we will talk about remote code execution and CSP. We will get remote code execution and see a nice CSP bypass in Bitwarden using techniques that work for bypassing CSP in various platforms. Then we will take a look at data exfiltration, right? Because you can use XSS to steal data from the application. We'll take a look at drag and drop XSS and other kind of more advanced attacks. And then we will also look at getting code execution using IPCs, right? So this is one of the other topics that we will cover today, right? Because, well, it will make more sense when I explain it later, but this is one of the things we will talk about today, right? So we will take a look at remote code execution by attacking the preload script, code execution with no integration, with lack of context isolation. I will explain what this is now in a moment. We will use like URLs, XSS, and IPC, so different ways to get code execution. We'll talk about mitigation as well. Then we will also mention code execution without context isolation, with a normal click, with middle click, getting reverse shells, and other things like this. Then there's another man-in-the-middle lab with a more kind of advanced exercises. In here, we will play with Discord, which is another application that is written in Electron. And then we talk about remote attacks, right? Because when we talk about Electron, we think normally desktop applications, but we actually found this like a couple of months ago in a pentest that Electron was being used on a server, right? So learning how to attack Electron applications can also be useful for you in a web application assessment, because you can use all the techniques to attack Electron applications to attack a web application if the web application is using an Electron component, right? So this is one of the exercises we will look at here. And I think there's no patch for this vulnerability yet, so you could call it that we have some 0 days in the course, right? And then there's local attacks. So we will talk about privilege escalation and leaks and WebSockets. And then there's another CTF at the end of part 2, right? So with that, that is what the course is about. And now I'm going to give you a few samples so that hopefully you come to NULLCON to enjoy all this. So in Electron, when the application starts, so this is the Electron application, right? So let's say you have Discord and you click on it, and then the application opens. So what happens is there's a main process that is being opened, and then this main process will launch some renderer process, right? It can launch only one, or it can launch more, but this is the main thing of how Electron works, right? So application, main process, and renderer process. The renderer process is what the user will interact with the most, because they are in charge of showing like screens to the user, right? So when you look at the Electron security settings, they are always more tuned to protect the renderer process than the main process, right? So the way this works is we have the operating system. So the operating system has a kernel, and then the Electron core is what is going to be talking to the operating system, right, at a low level. So it's going to say, hey, write this file, give me the contents of this file, and all that stuff. And then inside of Electron, we have what I said before, a main process and a renderer process. So both of them can invoke functionality from Electron, and they can talk to each other through IPC messages, right? So IPC stands for inter-process communication. So it's similar, if you are familiar with Android, to Android intent, right? One app can talk to another sending an intent. So in Electron, there's IPC messages for the renderer and the main process to talk to each other. What is important to remember here is that the main process always has more functionality, it's more privileged, and the security settings typically apply less to it. And the renderer process has less functionality because it's more exposed to the user and more likely to be attacked, but they both share some functionality. Now, Electron applications are all based on Node.js. So a lot of Node.js, a lot of the techniques that we will see in the course for Electron have techniques that will be useful for attacking Node.js applications as well, or defending Node.js applications, right? So let's take a quick look at how to get started with an Electron application. Now, one thing that you can do if you have, let's say, not much of an idea, is to run the npm audit command, right? So this command will be useful not just against Electron, but against Node.js and any other application written in JavaScript. So, for example, React applications, PhoneGap, Apache Cordova, Ionic, any application that is written in JavaScript. Typically, you can do this npm audit, and this will try to find vulnerabilities in dependencies, right? So this is where the exercises start, right? And I will do a demo as well, so you can use all these as an exercise in your own time. If you email admin@security.com, we can give you access to all this for free to play with, right? So the first time you run npm audit, you're likely to encounter this error, which will show you that there's a missing package.log.json file. So the reason for this is that when you run this command, npm I and then package log only, this will resolve all the dependencies, because nowadays we are in a time where the applications don't have as much code as they used to, right? They inherit a lot of functionality, so you can have a dependency that has another dependency that has another dependency, and things like this. So for this, you can run this command, and this will resolve all the dependencies and provide the list of dependencies here on the package.json, which is a file this command will create. And then when you run npm audit again, you should be able to see a list of vulnerabilities affecting the application that you are testing, right? So an important thing to bear in mind here is that it's only a matter of time until vulnerabilities in dependencies are discovered and made public. Hence, a perfectly secure application could become vulnerable down the line, as issues in underlying libraries are found over the years, right? So this is bound to happen, right? Vulnerabilities are going to be discovered, they're going to be published on the internet. So even a perfect application could become vulnerable, right? So for this exercise, if you want to do it and follow along, you should download the vulnerable1 application. So when you're looking at an Electron application, one thing to look at is the package.json file, and here you're looking at the main entry, which will point you to the main JavaScript file in which that will be called first by the application. Okay, so in this case, we have this main.js, and here we can see there's a new browser window, right? So this is what is creating the render process that I talked about from the main process. And here on the web preferences, we have that node integration is set to true and context isolation is set to false. Both settings are insecure, and I will explain why now. So node integration is bad or insecure because it allows you to invoke any Node.js functionality from JavaScript, right? So this increases the impact of a potential XSS vulnerability from being just an XSS of alert 1 to being code execution. Right, so it increases the impact of XSS on the application very substantially, right? So we turn it from XSS to code execution directly if node integration is enabled. This used to be the default in Electron. Now it is in newer Electron versions, it's no longer the case. Another insecure setting that this vulnerable application is using is context isolation. In this case, context isolation is set to false. And this is bad because it means the preload script is running in the same context as the application. So this will make more sense a little bit later on, but basically this allows us to use JavaScript to alter functionality in the JavaScript code the preload script is running sometimes, right? It depends, it needs to be like some stars need to be aligned, but sometimes this is possible. Right? This insecure setting is in place. So does anybody see a problem with this? Any guesses? I'm going to check the chat. Inner HTML, yes. So, yes, this is inner HTML. Is basically assigning the messages being assigned to inner HTML, which is a sync, right? So this will turn the message, which is the user provided input, into XSS, right? So yeah, this is the problem here. Basically, when we were talking about things analysis, we have the source of the input, right? In this case, the message that the user sends, and then the sync, which is the place on the HTML where this is going to be assigned. So when this is assigned, now we got XSS, right? So if you are interested in learning more about DOM XSS syncs and sources and stuff like this, you can look at the DOM XSS wiki. It has not been updated in a while, but it's still quite relevant for the most part, right? Another thing that you can do is to run electronegativity, right? So you can do npm install and then doyonsec add doyonsec and then / electronegativity -g. So this will install an electronegativity globally. And from there, we can now run this tool, right? So you can do electronegativity, and then you pass it the directory where the code of the application is. And then this will run some checks, and it will give you some vulnerabilities, right? So if you are not very familiar with Electron applications, this is a very quick way to get started, because it's going to look at the configuration and show you what the problems are. And then it will also give you like some links for you to check what the vulnerabilities are, right? So I'm just going to do a demo about this. So I think you can see my screen, right? So what I mentioned before was that when you run npm audit, right, the first time you're going to get this error message, and then you have to do npm I package lock only. So this is what I did here. I did before so that we save a little bit of time, right? So this resolve all the dependencies here, it already tells you about the vulnerabilities, right? And now I can run npm audit, which I'm doing here, and this will give us a list of the vulnerabilities affecting this vulnerable application, right? So we have npm audit, and this is the output, right? So we have a critical remote code execution through the Electron version. Here we have another code execution by re-enabling Node.js integration and things like this, right? So this is a quick way for you to find vulnerabilities with npm audit. And as I said before, this will work against any application written in JavaScript. Now let's look at the configuration, right? So what I said, but this is the vulnerable one application. I'm going to look at the package.json. Here we're looking for this main entry point, which points us to a file called main.js. So I'm going to look at that. So now if I look at main.js, here we can see there's a new browser window. These are the preferences, and here we have node integration set to true and context isolation set to false, right? So these are the settings, and this is how you normally find them. Now the vulnerability in the renderer that we talked about is like this in the code, right? So we have this code handling a link, right? So when the send button is clicked, then the message from the user is received and it is assigned to inner HTML, right? So that's the vulnerability. And now I'm going to run electronegativity so that you get a feel about how this looks, right? So when you launch it, you will see this ASCII art here, and then it performs the text, right? And this is how the output looks like. So these are all the issues that it finds on the application. Now, electronegativity is only looking at the configuration pretty much, right? So this is not a replacement from a real pen test or a proper audit, but it can give you a very good starting point, right? So we have here the auxiliary check, context isolation check, and all the things like this. And then you can click on these links to read more about those topics, right? So, okay. So with that, let's move on now to actually exploiting this XSS, right? So what does XSS mean in a desktop application, and how to turn XSS into remote code execution, right? So Let's first talk about the basics of XSS exploitation. So we will use the vulnerable one for this. So one thing to bear in mind is when you have the source code of an application, you have to npm install first, and then you can npm start, right? Because first you need to install like all the dependencies that Node.js, Electron, and any other dependencies that the application has, and then you can start it. If you try to start it without npm install, it will not work, right? So the first thing that we can try is to send like some payloads, like for example, script alert 1 or SVG on alert 1, things like this, right? And very useful for debugging this kind of stuff is to use the developer tools. So in Electron, you can open the developer tools even if there's no menu for it, using these key combinations. So for example, if you're using the Slack application or the Skype application or the Discord application, you can do Control-Shift-I, and this will open the developer tools. And from there, you can play more or investigate more what the application is doing and how it is output encoding content and things like this. If you're using a Mac, instead of Control-Shift-I, I think it's Command-Shift-I. Okay, so the first thing that you will notice in this particular application is that when we send script alert 1, for example, the payload is not encoded, but we don't get the alert, right? So there's something wrong. And this can get you confused, right? If you are used to web application testing and you try this, it could work, but in this case, it doesn't happen, right? And the reason for that is that in here, it does not work because according to the RFC, if the page has already been rendered, script tags don't have to execute again. However, we can still use an image tag, and then we can put like source equals X, and then on our alert 1, so X doesn't exist as an image, and then the on error event will fire, and then we get the alert 1, right? So this is what the HTML looks like. And here, because what I said that when you have node integration, you can invoke Node.js stuff. We can invoke all these node integration things to get code execution. So an XSS immediately becomes code execution because node integration is enabled, right? So we can do, for example, alerts, require child process, exec-sync, calc, and then to string so that we can see it on the alert, right? So in here, we can see, for example, the output of the ID command, right? So you run the ID command on the app, and this is how you can see it here, right? So when node integration is enabled, any XSS in the application means code execution. So now let's talk a bit about how to fix this, right? Because as I mentioned, I wrote this course a while back about fixing and defending web apps. So there's a little bit of this on the desktop course as well, because we will talk a bit about having a layered approach for defense, and then you can see like how things stop working and still work or not, and all this, right? So the first thing we will do here is to disable node integration. So this will turn off the code execution part of the problem, right? So now if we try to use the same payload again to execute the ID command, we will get this require is not defined, right? So on the developer tools console, we're getting this error message because we can no longer use require. Require is not available in normal JavaScript. This is only available when we have node integration. So this is a Node.js thing, okay? So that's the first layer, to disable node integration. Another layer is to disable CSP, because if we try image source X on our alert 1, this payload is still firing. So we have not fixed the XSS yet, so we can still add another layer of protection, right? So we can add a content security policy line like this, and then this will prevent the image source X on our alert 1 to fire, right? So now we will get, when you try this payload, we will get refused to execute the inline event handler because it violates the following content security policy directive, blah, blah, right? So CSP is now blocking this attack, right? So that is another layer of protection that we can use. And then we should, of course, fix the XSS itself. So one way would be to avoid XSS sinks. So as I mentioned, when you assign user input to inner HTML, location, href, iframe source, and many other things like this, you will have XSS. So one way to avoid the XSS is to avoid the sink. So instead of assigning the message to inner HTML, we can assign the message to text content. So this will result in fixing the XSS, and this will no longer be vulnerable, right? So now if you try to send the same payload, you will notice that it doesn't fire. You see the text here without any encoding and without any, the alert doesn't show up. So this is all output encoded correctly. And if you look in the console, all the HTML characters have been encoded. So we no longer have XSS, right? And now another possibility is that, let's say you have a rich text editor, or you can allow users to highlight certain, certain letters or something, like use bold, underline, things like this. And then you need some HTML, right? So for that, there's some libraries that can help you with this. So for example, the Purify. So this is how to install DOM Purify in the Vulnerable One application. We just do npm install DOM Purify, and then it will be added as a dependency on the package.json. And what we can do is then do DOM Purify, require DOM Purify in the code. And then we can, instead of having, so first we had the vulnerable inner HTML assignment, then we had the fix by avoiding the sink. And here we are still using the inner HTML, but we are sending this first through DOM Purify. So we're doing DOM Purify sanitized message. So the message will be sanitized before it is assigned to inner HTML. So when you try some payloads like this, like image source X on alert 1 or href JavaScript alert 1, you will see that all the bad stuff in that HTML is removed, right? So for example, the image source equals X is all that remains, but the on error alert 1 is removed by DOM Purify. Okay, so I'm going to do another demo about this. So I'm going to start the Vulnerable One application. And okay, so hopefully this is big enough for you to see. This is the console as well. I'm going to make it a bit bigger. Okay, so now if I do, for example, script alert 1, you can see this doesn't work, right? It doesn't seem to do anything, but if I go here, I can see that if I go here, you can see, maybe you cannot see because it's too small. I'm going to make it bigger. Okay, that's probably better. You can see that script alert 1 is there, but it's not firing, right? So now if instead of this, I try image source X on error equal alert 1, and I send a message, now we get an alert. So this one is working, so this is XSS. And now what we can do is we can try all these node integration, because we saw before on this application we have node integration, so I can try these payloads, right? I can make this a little bit bigger so that you see it. And now you can see here, this is the output of the uname-a command in Linux. This is the output of the ls command in Linux. Now I think the calculator takes a little bit longer. Yes, so now it's the calculator. Now that's something else. And now we get the output of the ID command as well, right? So we have code execution while doing this, right? So now let's move on to attacking preload scripts, right? So this is, for this one, we will use the Vulnerable 2 application. So this is non-isolated world, right? So we have a preload script that assigns it has a window.abc variable and it assigns 1 to 3. So if there's no isolation, when you do alert window ABC, you get 1 to 3 on the render process, right? So in here we have no isolation. This is the default, and this is insecure, and we are going to see why now, right? So this is what it would be if it was isolated. So if you assign 1 to 3 to ABC and then you try to alert it inside of the HTML, this will be undefined because it is not, you know, it is not defined because it's isolated, right? So the two contexts are different. But what we can do is using XSS, we can modify the JavaScript function. So for example, if there's a comparison here using index of, we can make index of always return lead. And then whenever this payload is used, then the meaning of the index of function will change. So this check will always be true. And then when a link is clicked, it will always go to shell open external, which can be here, right? It can open it will open in this case the calculator as a proof of code execution, right? So if there's no context isolation, XSS on the renderer can access and modify JavaScript prototypes used in preload scripts, right? So here we have, we define safe protocols, HTTP and HTTPS. This is the click event, right? So the click event is here checking that if it is an A tag and the protocol is inside of the safe protocols, like HTTP and HTTPS, then it will open it to shell open external. So the Electron application is handing off this link to the operating system, for example, to open the link in the browser, right? The problem is when this link, instead of starting with HTTP or HTTPS, it starts with file. So we can get code execution without warnings in Windows, for example, using the Java extension, right? So we can send a file link, and then there's a linkifier that will turn this into a link. And when you click on it, then this would result in code execution. So there's this check. And then whenever you click on this, right? So you do, hey, look at this, and this is the malicious URL. Then when you click on it, it says this link is unsafe, right? So the check is good. But because there is no context isolation, we can modify the index of function, right? So this index of function that is doing this check to verify that the link starts with HTTP or HTTPS, we can change it here with an array prototype. So this is kind of a prototype solution of the actual the intended functionality of the application, right? So you do, hey, look at this, and this is the link, and then this is the payload to override the functionality of the index of function. So whenever you click on this link, now we will bypass this check, and it will always open with shell open external, which means we will get code execution, right? And the reason this works is because if we do like safe protocols, the index of HTTP, we get lead. If we get safe protocols index of file, we also get lead, right? So it's always returning that, and this is why it works here, right? So let me do a demo of this one. So I'm going to close this. And 3. Yeah, no, I think this one is on, this one we will do here, I think, yes. So I'm going to close this, and I'm going to open, so now I'm using a Windows VM instead of Ubuntu. And here we can try this, right? So if I send just, hey, look at this, and I send a message like this, and then I click on it, it's saying this link is unsafe, right? But if I paste it with this image source and then override the index of function, right? So if I paste like this, now we have here the broken image, which has executed our JavaScript, and now we are getting this code execution without warnings, right? So what we are doing is in the preload script, we are changing the index of function because there's no context isolation, right? So this is one of the other techniques. Now, this is a webinar. I'm kind of rushing things a little bit so that we have time for everything. But in the course, we go into a lot more detail. Now, I'm going to talk about the remote code execution with IPCs to finish up. So in this case, you can have the main process with a listener. So for example, the main process can look for an update, and then the renderer process exports this update, right? This functionality to so that from the HTML using an XSS, now this will be exposed. So you know, an XSS on the renderer will be able to invoke this get update if the renderer process does something like this, like exposing the IPCs, right? So what we can do is something like Electron send get update and then send a payload for a reverse shell. So the application then will go through this. And then another thing is that the middle click will bypass the click event, right? So you could also get code execution, like another way to bypass this would be if the user, instead of using the normal click, would use the middle click or the wheel click in the mouse, right? In that case, we can send an IPC directly to Electron like this, and then we will gain code execution. This is the output of all the commands in that for the middle click. And then using IPCs themselves, we can gain code execution in a number of ways. So if, for example, something exported like this, like Windows, Electron open in browser, and then we can call this with XSS, then if this is calling like shell open external, we can gain code execution that way, right? So there's like a lot of ways in which you could do this, but we will focus on the one with the update with different events, right? So we have here on the main process a get update event, and then there's a will download, blah, blah, blah. And then in here, when the update, it tries to retrieve the update, it downloads it, it assigns executable permissions, and then it will run it, right? So that is how this will work. So basically, the will download event fires, it will be saved. Then there's like executable permissions, then it will be run here. And what we can do is simply to provide our URL in a website that we control. And then the application will execute our code, and then we can gain code execution and get a reverse shell, right? So this is what I will demo now. So we need a netcat listener, for example, to receive the shell. And then this is the shell exploit. So we get a link like this, and then when it is clicked, we will gain this shell, right? So in the main process, it will show you like how it's working, like get update and the URL, and then it downloads it into the downloads directory. It assigns permissions to it. It receives some bytes, and then once the download is successful, it will run the update. So we gain code execution through a malicious update, right? So and then we can run commands, cut the password, and so on. So I'm just going to finish this demo, and then we can wrap up. So okay, so I'm now starting this vulnerable application, right? And what we can do is to run I'm going to use this link here, right? The Linux reverse shell. So I'm just going to copy this link from the slides in here, right? And then when I paste it, I have to check here that we have a netcat listener ready. And now when I click on this, we can see here that this open an empty window, but here we have a shell, right? So now I can do cut the password and so on, right? So this is because we managed to provide this payload, right? We managed to provide a link that when opened, maybe this is too small, make it bigger. So we managed to provide a link that when opened in Electron is sending an ITC, right? Is calling this Electron send and then get update, and then we give the path to our shell. So this is why we got the shell here. And here in the main process, we can see what the application was doing, get update of the shell, and it download the file, download successful running update, and then you get the remote shell, right? So these are all some exercises that we put together in the course based all on real pen tests. So I hope you like this presentation. Come to NULLCON for more. November 7th to 10th from 10 a.m. to 2 p.m. India time, right? The 4 days, but the sessions are only 4 hours for all audience levels. And yeah, if there are any questions, now would be the time. Let me check.
We have one question, Abraham.
Okay, should I check the chat or will you tell me the questions?
Okay, I'll tell you. We have a question. Is it safe to mention sandbox as a true without the nodal integration flag?
Okay, sorry, can you repeat the question? There was some background noise.
So the question is it safe to mention sandbox as a true without the nodal integration flag?
One second. Is it safe to mention?
Yeah, can you read it, chat box?
Sandbox as true? I'm not sure. We didn't talk about any sandbox here, so I'm not sure what it means.
Okay, we have one more.
The way it works is if you don't have node integration, so well, I can show you here what node integration means, right? So if I open, let me close this. So if I open the vulnerable one application, and this one, yes, this one is here. So if I start this application, I can run whenever there's no integration. What it means basically is that you will always be able to invoke functionality like this, right? So I can open, for example, the ID command, right? So this is because node integration is set to true. So I can run this, and then I get the ID, right? But now if I close the application and I go here, and I go to the configuration, instead of node integration set to true, I set it to false. And now I open this again. If I try the same thing, now we will get this error that I was talking about before on the console, right? So on the console, we should get now an error message, right? That require is not defined. I'm not sure if you can see that. I'm going to make it a little bit bigger. So we get require is not defined, right? Because we can no longer invoke Node.js functionality. So we are lowering the impact of an XSS from directly code execution to just XSS. Right? So we still have XSS here, but we can no longer execute Node.js stuff. So that is what it means. There's really no sandbox as such. I mean, it all works on the Google V8 engine, right? So Google V8 is used for Node.js and for Electron by extension. And yes, there is a sandbox in there, but that sandbox is more about isolating from the operating system. It's not as much related to this node integration thing. So hopefully that answered the question. If not, keep asking. Is there any other questions?
Yeah, we have one more question. Can Electron to invoke local system files by default?
I don't see that one.
If you scroll a bit up.
Can Electron applications use file URL to invoke local system files by default? Yes, this is possible, but there can be, like through configuration settings, there's ways you can lock it down, and we go through that over the course. So yes, by default it is possible, but it can be locked down. And there was another question, I think, what prerequisite web app knowledge is required to take the hacking modern desktop course? I think there's no prerequisites really. Like, this is a webinar, so I went really fast, but in the course, we start from the basics and then build up from there. So I think even if you have no idea about web security, you will be fine. The only thing is maybe you will complete less of the lab, so you will be a little bit slower, but this is all fine because you have access to all the material forever and you have unlimited email support. So if, I don't know, it takes you like a little bit, like later on, like during a month later after the course, you ping us with some question, we'll be happy to answer it. So you always get more out of the course. So I think it will work fine regardless of skill level. But one thing we do in our training courses is we put a lot of material. So if somebody is advanced, they will also not be bored and also learn a lot out of it, right? So that is what we try to do. Any other questions?
We don't have any questions. Participant, if you have any question, you can type in a chat window. Okay, we got one question.
Scope of Electron-based cybersecurity.
Yeah.
I'm not sure what the question is.
Yeah, same.
But we covered some tools that you can use, like electronegativity, NPM audit. Those will be some tools that can help. Thank you for the feedback. And then there's another one, NPM is used where Electron is there. I suppose, yes, NPM is typically always used in Node.js and Electron projects. So yes, NPM audit, that command will work against a lot of JavaScript applications. Like even for mobile applications, if you have source code, it will also help you, like for Cordova and Ionic and PhoneGap and all these platforms. React is also another, React Native is another platform for writing mobile applications with JavaScript that will also work.
Okay, so look like there is no more question. So in that case, I conclude our today's session. So thank you, Abraham, for this really informative session. I'm sure like our attendee must have found some knowledge inputs from it. And thank you all attendees for joining the today's session. We hope you all can join us for the future sessions also. So thank you, speakers and attendees. Stay safe and healthy until next time. Thank you.
Thank you.